My name's Tony Caputo. I'm the practice leader for design at Array Architects. It's a big picture of me. We are a firm, about 120 people, 8 offices. We practice predominantly on the East Coast, but we go as far west as Dallas. And as the practice leader for design, I'm sort of concerned with a couple things about the way we practice. Today I'm going to talk about the developments that we have in the industry, how we're utilizing them to develop sort of internal team communication, ensure the continuity of information across projects, and sort of deliver them to sort of build form to our clients. The thinking about that is what we're really doing on every single project is we're in the practice of making architecture, and I guess I'm in the Alberti camp, right? In the way of when we began to be able to see how to communicate and draw and communicate that with other people, it sort of opened up a new world that was a little different than the sort of physical aspects of just the making, because we could do that sort of detached and isolated from it. And I start to think about how, moving forward in the future, how that interface of what we see and how we draw will be. Now that we're mobile, we're also agile. So part of my process, a little bit, part of the way we work is we usually start everything in a very portable mode. I'm using apps like Format from Autodesk and other apps to actually model, to do computation and analysis, and communicate that with the team. I'm able to do things directly within that, like set exact geographic location for a project site. So I'm getting accurate weather data, I'm getting to-scale information, I'm getting geographically correct information, and I'm able to do iterations of designs virtually now on things like an iPad, basically from anywhere I'm moving. I can do various design studies in that virtual mock-up, and I can also now, by connecting this back to spreadsheets and databases, I can do things like before I start designing the way things look, I can use things like studying code analysis, working with a developer, for example, to study various iterations of building footprints and shapes within a site relative to zoning constraints, and how that drives back into a database of, say, BOMA calculations that feed right into their pro forma before we're even doing schematic design. So early concept design, driving information that's based upon, say, some of your owner's metrics that help feed results of how you move forward with the project. And then this idea of being able to share that from like doing various versions of this, say, on the laptop in Format, and uploading that to a program like Autodesk A360, which is storing those files and saving various file types, sharing them with the project teams, and the project teams can then take concept models and things that I begin to develop based upon those things and bring them into the Revit model. And the Revit model we keep at what I call home base, right? So that's where a lot of the production model comes out of. Looking at various versions of how you would implement, say, a solar study and how that is affecting the facade of the building, so that the information gets drilled into the individual components of the building through things like scripting now. And then being able to still, with Autodesk Format, being able to start the projects there, looking at early analysis. So there's a basic energy model and components built into this so that we know our basic building masses, configurations, we can assign building types, we can assign window area, and we can start to make informed decisions about the building in a sustainable manner that are driven by real information about the project. Again, drive that down into specifics from the energy model and look at different design ideas which respond to, say, solar gain on the facade. So if we want to develop in this idea on the left-hand side, you see an articulated facade. The idea was to generate from the solar analysis and the energy modeling a facade which shaded itself and also responded geometrically to the different lighting conditions cast around it. This is that facade you can see on the west. It's a constantly varying angle over the length of the building. So by going back and forth into the parameters, driving into the facade and understanding the lighting conditions, we're able to get basically the building form, which is driven by something other than just formality. So working with manufacturer, another coating manufacturer, Guardian Glass, has a series of tools which then allow you to create specific compositions of your IGUs. So for this project, we then took the geometric information, combined that with specific glass components, and then Autodesk has provided, there's a spreadsheet which converts the glass composition to specific RGB values, and Guardian then will create a component family for your curtain wall with those specific characteristics, which you can then plug back into the Revit model and do luminance diagrams, for example, to really understand, by changing the glass types and the composition of that in the model, what the quality of light and glare and things are going to be within the space, and ultimately getting a true representational rendition in color and accuracy of what that space is going to be like before it's built. And then talking about how you would then take this system and the thought of building 270 feet of every 5 feet, basically changing tenths, of degrees in angle, how you would do this type of thing now. We have the ability with the BIM model and with that information to generate data sets, accurate control points, and feed that back along with the model to fabricators, with this idea that the majority of fabrication being done now is being done in a factory. It's all CNC controlled, and that these components were all built off-site and effectively brought to the site and installed as singular units.